Hey y'all, welcome back to the Database School podcast where I talk with people in the industry about the stuff that they're up to. And today I talked with a senior engineer named Preston Thorpe. He is deep in this rewrite of SQLite. He is also in prison. Currently, actively in prison right now. It's a very interesting story. He turned his life around once he was inside. He learned basically all there is to know about databases. This is just such a good interview. He claims he has a lot of time inside. There's not a lot to do, and so he just spent all of that time learning and researching and bettering his life, and he landed a remote job. He is a proper senior engineer at Turso, the database company, and he is actively in prison right now. He is incarcerated. Very, very inspiring story. So we talk a little bit about that up front, and then we go into all of the stuff that they're doing to rewrite SQLite in Rust, and all of the challenges that they've come across trying to write a database from scratch, which is objectively crazy, but also very awesome. So I hope that you like this episode, and if you do, I would love for you to reach out to Preston. I'll leave links down below. Reach out to him and just tell him, hey man, I listened to your interview. Like, keep going. You're doing a great job. And at the end, we talk a little bit about when he gets out and his plans for after he is released from prison, which is coming soon. So I hope that you listen to this whole thing. I hope that you reach out to Preston and give him some encouragement. I would love if you would subscribe to this channel, leave a rating or review for the podcast, go to databaseschool.com, do something. I don't know. It's a little bit of a muddled call to action, but please do something. Let me know what you think. And if you want to hear somebody, one of your favorite people on this show, leave a comment who you want to have on, and I will try to find a way to reach out to them and get them on. So enough yapping from me. Let's go talk to Preston Thorpe from Turso. I am here today with Preston Thorpe. Preston is a senior engineer at Turso, which is the SQLite database company. I've talked with Glauber, the CEO of Turso, a couple of times, and Preston is a senior engineer over there. Preston, do you want to introduce yourself any further?
Yeah, I guess I'm Preston. I'm a open source developer. I've been working at Turso since May of this year. I've been contributing to Turso DB since almost this time last year, so about a year now.
Perfect. Okay, so first question. Well, let me explain quickly Turso. Turso is SQLite company who is currently in the process of rewriting SQLite from scratch to support a bunch of new features. And so we're going to get into that because it's launch week right now at the time we're recording, and there are just some incredible things coming out of Turso. But before we get into all of that, Preston, where are you calling in from right now?
Yeah, so I'm Mountain View, maybe not the Mountain View that people are expecting, but yeah, so I'm at Mountain View Correctional Facility in Charleston, Maine. I'm currently incarcerated in Maine State Prison System, and yeah, I've been kind of got special permission to work remotely. Something that happened about 2.5 years ago, and I had taught myself to program like while in prison, over the last 3 years or so.
This story is just absolutely incredible. So you've written a couple of blog posts, which we will link down in the show notes below for anyone that wants to read the full thing. But you are, like you said, currently incarcerated. You are in prison for nonviolent offenses. I don't know how long you're there for, but you are actively in prison, and you are a full-time senior engineer producing meaningful work for this company. This is incredible to me. It's very much I've read all your stories. I've talked with Glauber a couple times because we're local together, and it's just such a redemption arc that is just really encouraging and inspiring, frankly. So tell me a little bit about how you got from being incarcerated to basically turning your life around while still being incarcerated. That's the most amazing part to me.
Yeah, normally it's tough because you're so limited in what you can actually do about like changing your life. Like, uh, you can, feel and have whatever kind of like meaningful internal changes, but typically there's no way to like act on that in any kind of, realistic way, and there's really no way to prove that you've made any changes to any loved ones outside. They're kind of
Mm.
probably used to hearing it after like so many years. So just like having the opportunities up here to like it like it feels really good to finally have my parents like be proud of me after all these years of just being a total screw up. But they provided the opportunities here to like do something real, and it's like I feel like the accomplishments and just like what I've been able to like achieve like make it very clear that there have been some pretty drastic changes in my life, and I'm super grateful for these opportunities.
Yeah, this, I mean, yeah, I'm gonna talking about your parents being proud of you. Okay, whew, as a parent, that one hits me pretty hard. So how long have you been incarcerated this time? So you said like 2.5 years ago you picked up, studying pretty heavily, and then in May you got hired as an engineer. How long has this stint been this time?
So I've been incarcerated since May of 2017. So I have
2017.
been in for 8.5 years now.
Okay.
Um, in mid 2022, I enrolled in college, and that happened to be the first semester that they had kind of like allowed laptops, and there was
Okay.
some form of access to the internet.
Uh huh.
Um, and prior to getting like a laptop, like I was really into finance, and I was like gonna teach myself to, I was gonna like try to trade, day trade or whatever.
Mm-hmm.
Like that was kind of my way out that I saw. But getting my hands on a laptop, and then having at that point like 4 years left, or I kind of had an epiphany of like, because I programmed in high school, not like a ton, but this was like '06, so
Mm-hmm.
it was a lamp, Perl
Mm-hmm.
like that, so had this kind of epiphany of like wow, like who has uh, 16 hours a day
Mm.
for years to spend learning something. I was pretty much starting from scratch, but just the like, in tech, people have fancy degrees and all that, but at the end of the day, we all kind of know like what matters is like if you're good, you're good,
Mm-hmm.
and they don't really care about your background or
Mm-hmm.
generally, right? So yeah, since that day, I decided that this was going to be what I do, and uh, yeah, pretty much spent 16 hours a day for, this was like 3.5 years ago.
Mm.
Um, I got hired by a company called Unlock Labs. Shout out Unlock Labs, they're amazing people. Co-founded by formerly incarcerated uh, individuals that were sentenced to life as juveniles,
Oh.
and got out. And now they build education software for incarcerated learners. So I was fortunate enough to get hired by them after not a whole lot of time. Probably only spent 8 months or so, kind of like on the 16 hours a day of learning before I got my first job,
Mm.
and managed to like uh, excel pretty quickly there. Ended up leading a team of like 7 at one point, and doing like hiring and interviews, and uh, ended up eventually like was like their principal engineer, and built all their infrastructure and wrote the pretty much all the whole code base, and uh, yeah, it was a really great opportunity. I had a really good mentor there. Shout out Noki. Um, and yeah, the whole time I was like spending my free time contributing to open source projects.
Mm.
I've always been a lot more interested in lower level kind of systems stuff. Rust was like second or third language I learned getting back into programming. So in like October or November of last year, I saw Pekka. I don't know. I think they like wrote a blog post or generally like was. I follow him on GitHub, so I think I saw back then it was called Limbo, and saw that repo and saw how early on it was. Looking at the code, and I was like, wow, there's enough like low hanging fruit. That even I can reach some of this fruit, right? So it was. I remember kind of realizing like, wow, like there is lots of work to be done. I could really cut my teeth on this, and just went headfirst into like databases and SQLite and watched every Andy Pavlo CMU database group lecture and read so many academic papers and database internals, and I just like have been obsessed with it since. Spent a pretty tremendous amount of time working on that, and eventually Glauber reached out, and I remember like being active on the Discord community and like communicating about the work, and my story's been out there. I wrote a blog post in was it 23, I think, like September of 23, that ended up going like pretty viral on Hacker News. It was on the front page for a few days, and my story was on my GitHub, but it just never came up. Like I was like participating in this community, and it was just kind of like, I was like, I don't know if they know that I'm in prison or whatever. One day he reached out and he's like, hey, I'd like to talk to you or whatever, and we ended up and mind you, at this point I already have I'm like running this team, and I have a job and stuff, so right. We ended up becoming like pretty close over the course of months, and the idea never even really was like floated that I would actually like work for Turso. And eventually one day he's just like, hey man, we'd like to have you come work here, and I was like, yeah, no, I could probably work it out. I just gotta give the team, like, he's like, no, like we'd like you to start like today. So that was fun. Ended up having to make that work, and kind of worked two jobs for about a month, and while I got the other team ready to go on without me. But yeah, I've been working full time since May. It's been a total blast.
Okay, so bunch of questions. So we're gonna back up and go through a couple of them, and then I want to hear about some of this Turso stuff that y'all have been doing and launching. So you said you enrolled in like college while you were inside. I think that was like in 22 you mentioned. So what is the like? I have to imagine you're incredibly unique where you are. What kind of switch flipped for you that you were like, listen, I don't remember how long you said, I've got many, many years to go here, and I'm going to spend my time like bettering myself, learning new things. Maybe it's finance, maybe it's computer science. Like, what was that process of, man, something's got to change here?
Yeah, it definitely started coming up to Maine. So I was sentenced in New Hampshire, did quite a bit of time in New Hampshire prison. It's a long story, but I ended up getting sent out of the whole state. They weren't interested in me being there anymore. So I ended up getting sent up to Maine, and it's just a very different environment. Prison's not a nice place. Believe it or not.
I believe it.
Prison is not not a good environment. It's not. There's no positivity or like, and the things that make prison suck are much more prevalent in states other than Maine. So coming to Maine, it was just being away from all of the people that had kind of influenced me. Unfortunately, like when I was younger, I first went to prison at age 20. So, I kind of grew up in prison. So being away from all that and just getting like a clean slate and just being in a better environment, kind of, I this was during COVID too, so there was really like there was nothing else to do other than work out for 3 4 hours a day, and uh, like it was just refreshing to like not have to worry about the drama and the BS, just the negative kind of prison. Uh, it's like a whole culture. It has its own subculture, and there's all kinds of just stupid stuff that goes along with it. So being away from that, and then yeah, just I was literally just in epiphany. I remember waking up one day and just going like looking around and just being like, why am I okay with this? Like, when did I just accept that this is okay? Like, at what point did I say that this is my life, this is who I am? You know what I mean? Like, before it was like an identity that I wasn't proud of, but I just accepted it. And you get sentenced to 10, 15 years, like, you accept everything that comes along with it, right? So there was just a day where I was just not willing to accept it anymore. And I used to watch TV and see people that had like a family and like a good career and a house and normal things, and I used to think like, man, like I threw all that away, like that's all gone. So yeah, there was just a day where I just decided, like, you know what, like that I'm done giving up on that. Like I will do what it takes to kind of make something of myself, and that's kind of how the positivity arc started.
Man, that is, I won't even begin to pretend I understand how difficult that process was, but it sounds incredibly difficult. Just being in that environment, and from what I've read of what you've written, it sounds like the environment is basically, hey, you're here forever. And if you say like, yeah, this is, I'm not coming back, everybody just laughs at you and they make bets on, how long it'll be before you come back. And the whole mindset is, this is your identity, this is your life. And that just sounds brutal. And so you go through this process of, educating yourself, and then you get this job at Unlock Labs. Is that a common thing to like, at this institution, to be able to take remote work, or was that kind of an exception?
No, definitely not. So, especially back then, this was, like I said, the semester that I enrolled in college was the first semester that laptops existed. And maybe like there was some before, but it was certainly not, they were not in your cell, right? And uh, it like, there was like the seeds had been planted essentially of the possibility that we were going to be allowed to work. But I was actually one of the first like handful of people that were like specifically kind of hand chosen to be able to work, because back then it was not in policy. There was nothing like on paper that said it was even allowed. This was something that was like you needed direct, like explicit permission from like the warden and up to be able to be in that position. So no, certainly not common. And now that it's in policy, it's it's more common, but it's still like you know uh, where you're not able to like physically be somewhere, like the number of people that have a skill, like you know what I mean,
Right.
that people are
Yeah.
willing to pay for, and is it's just going to be a fundamental issue with getting certainly not everyone's going to have remote jobs, right?
Hmm.
But yeah, certainly it was not common back then, yeah, at all.
And so you think you were probably specifically chosen because you have demonstrated this like intense desire to learn and be productive and presumably good behavior, and they were just like, "Hey Preston, do you want to try this?" And you were like, "Yeah, let's do it."
Yeah, like so the with laptops like came a whole bunch of problems that I'm sure you can
I'm
imagine,
sure.
right? So yeah, from the very beginning, the access to the internet and the laptop for me was like, this is my way out, like for sure, right? So, at the beginning, there was all kinds of problems that I saw as being this is going to like potentially end everyone's and is going to ruin it for everyone essentially, right? So, uh, you know, like I have been a computer geek since high school. So like even before kind of reteaching myself to program, like I was, knowledgeable enough about computers to be of like substantial assistance in general network administration and other things that they certainly needed help with at that time. So it was a lot of like me providing, helping them and kind of like earning trust. And because I'm also like needing, like the laptops were Windows 10 and locked down to the max. So like every time I want to install a compiler or whatever, it was like a process. So I'm kind of constantly like building a relationship with the administrators who are in charge of these things, and eventually they kind of realize like, wow, this kid really wants to do nothing but program is all he ever does, and that certainly contributed to that.
Man, that's awesome. Okay, so you're working at Unlock Labs, and you're contributing to what was then called Limbo. So for the listener, Limbo was the code name for, or I guess public code name for the SQLite rewrite. And that SQLite rewrite is now called Turso. And so Turso is the rewrite, Turso Cloud is the hosted solution. And so those are the names. And you mentioned someone earlier named Pekka. That's the CTO over at Turso. So there's Glauber, CEO, Pekka, CTO. So that's all the cast of characters. So then Glauber comes along and it's like makes you an offer you can't refuse, which is like, hey, come build databases with us. And so what is your area inside of Turso that you spend the most of your time working on? And then we can move into some of this launch week stuff that has been announced.
Yeah. So I would say I wear many hats. I have been responsible for things like the extension library. So building the APIs out to like make extensions like possible. We support runtime extension loading, which is not a common thing in Rust. And so there's that. I wrote the Go driver, or the bindings. And then other than that, I primarily work on, contribute a lot to the IOU ring, like async IO backend. I wrote a good portion of the write ahead log, so I've done a lot in like transaction isolation.
That is low level stuff, man.
The page cache, let's see, and then a lot of like query planning, translation, stuff like that. So I think I actually originally implemented indexes and recently did partial indexes, foreign keys. I work on everything. There's very few things that I haven't touched. I think the B plus tree is my nemesis. That is the one that is the one section of the code base that is just not for me, I think.
This is crazy because I've talked to a lot of people who are, pretty low level and building stuff, but just the concept of like, yeah, I built indexes and foreign keys and partial indexes. And it's just like, man, that is a level that I do not operate at. Writing the actual database. I consider myself a good user of a database, but actually writing the database sounds very difficult. What was the most, besides, I guess, B plus trees being the most difficult, what's the most enjoyable? Like, what part of all of that? Rust, Go, indexes, Linux, low-level stuff. Like, what is your favorite part to do?
I'm a systems guy, like POSIX APIs and low-level Linux stuff. I love IOU-ring. IOU-ring is an amazing piece of technology. It is like having a unified API for like truly asynchronous I/O is huge. I think it is underutilized for sure. I would say that my favorite part is working on probably the I/O layer. Like I'm a performance geek, anything related with performance, and yeah, the optimizer and the B plus tree. Like, I guess the difference is that I've worked on the optimizer a fair bit, the B plus tree, very little. But yeah.
Good Lord. Okay, so you're deep in the weeds of this entire like SQLite rewrite, and for the listener, the the motivation behind this rewrite is to add some features that are seemingly, and in my opinion, are missing from SQLite, and there are presumably no plans to add them to SQLite. So we're talking stuff like concurrent writers, and then you've introduced encryption and partially, partially recomputed materialized views, basically live materialized views. And so that is what the motivation behind writing Turso from scratch is. And SQLite is not, it's open source, but not open contribution or something like that. And so now here we are with, are we calling it beta or is it still alpha, this Turso?
As of this week, it is officially beta release.
Hey, all right. So we officially have a beta of a from scratch SQLite implementation. And I'm looking at the Turso blog, and I'm seeing 5 posts at this point: concurrent writes, encryption, WASM, Turso sync, and live views, which is that real-time materialized views thing. So y'all have done a huge amount of work. Which one of these do you want to start with? Which one of these gets you most excited about the future of Turso?
For me, I would say probably just concurrent writes, right? Like SQLite serializing writes is like top 3 easily like biggest complaints that people have when you bring up in general like what are the problems with SQLite. I think a significant portion are going to have serialized writes in there. So yeah, I think that's one of the most exciting features personally.
Okay, so let's talk about this. Talk to me about the effort and the architecture and strategy required to make concurrent writes a possibility, because one of the things, like you said, that SQLite always gets complaints about is it can do many concurrent readers, but it can only do one write at a time. And the answer has always been, well, turn on wall mode and it's probably fast enough. And then after that, you're kind of hosed. That's the last answer we have. And so one of the first things that Turso set out to conquer was this concurrent writes problem, which every other database has except for SQLite. So how did you all implement this concurrent writes in this new Rust SQLite port?
So yeah, that certainly not an easy feat there. The SQLite wall mode actually has it. There's a few really unique things about SQLite's wall that are maybe kind of questionably performant, namely a wall frame that actually consists of the entire page. So if you have a single statement, right, that does an update, that whatever page that tuple is stored on, on disk, is going to make up the entire frame, and then the next one is appended to the log. And it could be the same page just with an additional tuple, right? So you now have 8 kilobytes for 2 single statement updates. So this is
Let me pause there and explain to the best of my ability to the to the listener what we're talking about here. So when you turn on wall mode, that's write ahead log, and that means that there are now 2 or sometimes 3 files instead of just the one SQLite file. You've got then Aaron's database dash wall in there as well, and at certain checkpoints, the write ahead log is then put back into the SQLite file. And in the SQLite, the single SQLite file, it's broken down into these logical pages, which are just like chunks. And so these pages can contain many, many, many rows. And what you're saying is that in SQLite by default, when you do an update, instead of just writing just like that single tuple to the wall, which would presumably be very small, what you're saying is that whatever page that update or that tuple goes on, that entire page is copied into the wall. And then what you said at the end was if somebody updates something else that would update that page again, that entire page gets appended to the end of the wall again. So now you've got potentially several copies of this page where you're really only updating one row each time, but the whole page has been copied in. Is that accurate?
That is exactly.
Okay. I did not know that. That's a mess. Keep going.
So in the implementation of the wall, there is some other plumbing for multi-process support. Like there's an index file that's like a memory mapped, like shared memory file that is like used so that multiple processes can work with the same database file. But there's also in the wall implementation, there's also all of the transaction isolation plumbing is baked into the wall. What prevents a reader from reading, let's say you start a transaction, you have another transaction that began afterwards, and they append some frames to the log. Like what stops a reader from reading those frames, because of just kind of like how intertwined these things are, the log is not only for durability, right? Which is like typically that's the job of a log is gonna provide durability. If you crash, you go back and you like read the log into memory and figure out what was committed and write that checkpoint it over to the database file. So to be SQLite compatible with their to be able to open a SQLite database that has a wall, right? Like all of this needed to be rebuilt kind of to their spec specifically, and that is so to try and build essentially like concurrent writes like on top of something that was already just fundamentally set up to be serialized writes would have been really difficult. So they actually not me personally, I have not worked on MVCC a bunch myself, but something MVCC, multi-version concurrency control, is like a whole different transaction isolation system that allows for writes to happen concurrently by in different transactions and does all of the magic to make sure that readers can read and what they're supposed to. That has been a project going on for the last, I would say, like 8 months now, and there's been a big push right before the beta to kind of get it to a point where people can try it out, right? It's certainly not something that we recommend that people try to use, right? But it is really cool and I think very technically interesting, and it's been fun to kind of see that play out.
Well, if you tell people it's not ready for use, the first thing they're going to do is go try to use it, and they're going to try to use it in production. So y'all, it is not ready for production, but hey, maybe give it a shot. Okay, so backing up just a second, one of the things you said in passing was to be able to open a SQLite file. So you all are trying to maintain compatibility with vanilla SQLite files such that Turso can open those. What about the other way around? So like if you do you open a SQLite file, you run it in Turso with all these amazing features for a while, is that still openable by SQLite?
It is, and that's actually one of the things that we test. We test that at quite extreme levels by opening and generating files as part of we run a simulator, like deterministic simulation testing. So we quite frequently will do crazy amounts of writes to make sure that we're testing overflow pages and all of the fun little SQLite special kind of heuristics that that comes with their file format. A fun one we learned not long ago was that whatever page 100 gigabytes falls on is not used. We discovered that if you do what is it? I think is it 100 gigabytes? Or is it a gigabyte? Yeah, it's a gigabyte page.
Man,
the gigabyte.
That's pretty common then.
The gigabyte page is not used. Essentially, like the page is just discarded, and Nikita, one of our engineers, found in the SQLite codebase that it's just ignored, and we could not figure out why doing greater than gigabyte inserts would corrupt the database. And there was like a couple days where we just could not figure out like what was going on, because it was always at exactly a gigabyte that it would corrupt it. And it turns out that they just don't use that page.
Were there any Richard Hip comments around the code to describe why?
I think it was like, in case it's needed. It was like it was something like that. I'm sure there's like a better reason.
Which engineer among us hasn't done in case it's needed and then accidentally left it there for 30 years? Yeah, I've done that one before. Okay, describe for the listener. I would take a stab at it, but it's you're going to be better doing this one. Describe just kind of in brief, or maybe at a high level, what MVCC is, and just kind of like theoretically, how does it work? You mentioned the benefits, which is nobody's, stomping over data, nobody's reading data they're not supposed to read, but like, how does it actually work? Providing, understanding you didn't write that part of Turso, and so if you're fuzzy, that's fine. But do your best to describe we'll call me the noob here, what MVCC is and how it works kind of at a fundamental level.
Yeah, I could certainly give it my best, right? Multi-version, it is a bit kind of self-explanatory. Multi-version concurrency control. So, you have like an in-memory database, right? And we actually have a logical log. Like there's a physical log, which is you write some bytes, to and the offset of this tuple and the length into some bytes, right? That would be like a physical log, and then you have like a logical log is like it's a row, and we know like what the tuple is, and you know what I mean. So there's a logical log, and then in memory there's essentially a representation of a database, and a transaction has like a special transaction ID and a timestamp down to the nanosecond that determines like which one happened first, and there are multiple versions of essentially all tuples that are interacted with. Like there is a separate version that contains the appropriate changes relative to the time that the transaction started, and then whatever the transaction did. So essentially, it has its own special log, and then it keeps different versions of things in memory and resolves them. And gives us transaction isolation, instead of the alternative is to just have this append only log, and then you have, in wall mode, you have a reader that has a max frame, and that frame just says, hey, when a reader asks for page 50, that goes to the log before the pager and says needs page 50, and that log says, do I have a page 50 that has the frame number equal to or less than whatever the max frame is for that reader. So the reader's max frame might be 5 or whatever. So do I have a page 50 in the log with the max frame of equal to or less than 5? And it might have to read that page from the log instead of directly from the database file. So that's kind of like the transaction isolation provided by the wall is kind of much more simplistic, and it's not dealing with, I guess there's like multiple versions of pages, like because you have different frames, but you're not dealing with like semantically multiple versions of tuples in memory, and there's a lot more going on with MVCC.
And so if you're trying to stay compatible, and SQLite has pretty strict like file format stuff, obviously, where are you putting all of this extra data? Like, how are you carrying all of this extra information to enable some of these features without without corrupting either the wall or the actual SQLite file?
Yeah, it's a tough one. In order to use MVCC mode, right, there's obviously going to be some like, you can open a SQLite file, right? But like, you're not going to get the MVCC benefits if you open a Turso. You know what I mean? Obviously, it's not going to be like the other way around in that case. But if you use the wall journal mode, you will still get full backwards compatibility. As long as you stay within the features of SQLite, you get the same, you get the same amount of compatibility. And then the logical log, the plan is actually at the last I knew, the plan was to checkpoint the logical log to the wall, and that would allow us to only have to insert a frame. It like breaks that what we talked about earlier, where it's like one transaction for every page you touch. For each transaction, it's going to be another copy of that frame. That will allow us to only have as many frames as were pages touched, period, because we are able to checkpoint like batches of the logical log into the wall, and then the wall would immediately be truncate checkpointed to the database file.
Oh, I see. That actually makes sense. So is there a separate, so you're not trying to shove all of this, sidecar right along information into the wall. There's a separate log that you all are keeping. And so when you're using Turso, there's the SQLite file, the SHM, the shared memory file, the wall file, which is all standard SQLite. And then is there another log as well that enables this MVCC?
Yes, there is.
Got it. Okay.
We actually don't have a shared memory file yet. That is one thing that we do not yet support multiprocess, as that makes everything a lot more complicated.
I know that file exists, and that's about as far as I've gone, so I'll take your word for it on that one. And what kind of, so like, I know for the dear listener, we talked about deterministic simulation testing with Glauber on one of the episodes, so I'll leave that down below as well. But I know that you all are doing all of this massive testing, this fuzz testing, and simulating every sort of failure under the sun. What kind of improvements, throughputs, benefits are you seeing from this concurrent writes? Like, do you have any stats off the top of your head of like what kind of performance you can get out of this?
I don't want to freestyle anything right now. I know that there have been some promising benchmarks. Like throughput obviously is just not serializing writes is just obviously going to provide tremendous benefit there. But I don't know off the top of my head. Performance is something that databases being heavily I/O bound software, right? The like query plan optimization is like the most important thing, and the like optimizers in the land of databases are notoriously the most difficult like aspect of a database, and there's like a CMU joke that if you fail working on query plan optimizers, you can always be a rocket scientist, because they are very complicated
Yeah.
pieces of software. So yeah, like there is all kinds of improvements to be made there, and like we definitely are not generating the most optimal plans yet, and so like performance is always improving, and we're early enough on where like I think I spent amount of a few days not like terribly long ago, like rewriting the page cache, and got a like significant like kind of double digit performance improvement, and then again Pekka like fixed my rewrite and got again like tremendous. So there's any for any performance enthusiasts that might be listening,
Seriously.
lots of low hanging fruit, tons of fun, super fun code base to hack on, and especially if you enjoy writing optimizers. It's open source, and we would love
We need your
we
help.
would love the contributions there.
Let's talk about this. Speaking of extremely difficult things, this live views thing. So real time data with materialized views in Turso. And so I'm clicking in. I've read this already, but I'm clicking in, and it's like partially rematerializing. Incremental computation is what the H2 says here. And so from my understanding, this is also an extremely hard computer science problem to like compute the materialized view. So like say you've got a table or two, and you create this more user friendly, more usable query on top of it, and we call that a view, and now we're going to use that. When you want to update that, you have to run all the underlying queries that are presumably quite expensive to rematerialize that. But this is saying incremental computation, and so we don't have to rematerialize the entire thing. So how did we get here? Who worked on this one, and how did they pull this one off?
So Glauber actually worked on this, and
Really? As the
one
CEO, y'all still let him code. I guess the proof is in the pudding.
for real. I have a tweet that screenshotted that the diff of that PR, and was like, "Is your CEO dropping 8,000 line PRs?" Now he is
Hopefully not.
he
Unless it's
is
Glauber.
he's a beast, absolute legend. And I wish I had the. So this is actually based off of a paper. It's like a academic paper that talks about yeah, like I cannot think of the name off the top of my head. I was like trying to Google it here while you were saying that.
Yeah, I
But
feel like there was a company based on that. It was like Ready Set or something. Is that there was a transparent database cache for Postgres and MySQL sits in front of. I think this was based. Is it like the Noria paper? Does that sound familiar?
uh,
I feel like
let me see here.
uh,
There was a. We actually had uh, like a company meeting where they talked about
yeah,
where they kind of like
Noria.
announced this paper, and yeah, I of course this yeah, I cannot find it,
That's okay.
but
We'll find it and we'll put it in the show notes. But I think I remember this paper coming out, and Ready Set says it was an open source research project database Noria, which was built at our time at MIT. And so I think this is the same thing. But yes, I do remember this academic paper coming out, and I know PlanetScale tackled an implementation of this. I think ReadySet is another implementation of this, and so that is what this incremental computation of materialized views. That's what this is based on at Turso as well.
Yes, essentially. Yeah, I'm not. Like I said, I'm not 100% on this. Okay, here we go. Is this what it is? DBSP, Automatic Incremental View Maintenance for Rich Query Languages is the name of the paper.
Okay, that might be a different one. I'll have to look that up. DBSP. Okay, DBSP. Cool. Database Stream Processor. Okay. Yeah, I see it here on ArcViz, or how do you say that? Archive? Is that how you say it?
Archive. Yeah, I think it. Yeah. Oh, yeah. Okay. Yeah. I actually don't. I would have said. Yeah. I guess it's archives.
Yeah, I guess
archive.
So. All
yeah,
right. Well, now we found the paper, so I'll put that down in the show notes. And so, when you're talking internally, what are the use cases? What was the reason behind building this incredibly difficult feature? Who's asking for this? What's the use case? Why, when, and where would we use it?
To the best of my knowledge, it is due to performance issues with traditional views in SQLite. This is a kind of a particularly challenging, as we said, implementation to reduce the amount of maintenance required for refreshing these views, and it does some for anyone brave enough to read the paper. I applaud you. It is quite a chunk of information there. But yeah, the motivation, as far as I know, was issues with, and essentially I'm not aware of it being a particularly popular feature with SQLite, and I think this was an improvement that the community had asked for. So we looked into this.
Yeah, this is extremely difficult. I remember from conversations at PlanetScale how difficult this is to implement, and it says that Turso implements the following operators from DBSP. So it implements joins, filters, aggregates, and merge, which is it's a lot. That's pretty impressive. And it makes a note that recursive CTEs are not yet implemented, which we'll give them a pass because recursive CTEs and materialized views sounds like quite a bit. And so some of the other things that y'all have announced this week are the sync, the Turso in the browser with WASM, and encryption inside of the Turso database. And so presumably these are all things that people have been asking for. I know for one, the sync is something that people are super hot on, in the past maybe year or two, is these sync engines. And so to the extent that you know about the sync, tell us what's going on with the sync and what's kind of the promise of Turso sync here.
So yeah, sync is super cool, and something that people are really excited to use. So we actually have sync is in beta through Turso Cloud right now. Turso Cloud is running off of libsql, and we have the Turso server, which essentially pushes and pulls wall frames between client and server to keep state synchronized. So the idea is that you can have do a bunch of writes kind of locally, and then periodically, maybe when you're online, maybe you do those offline, and then periodically you're able to push those wall frames and update the state of the remote database. So there are that is cool and useful, but there's lots of room for improvement there, and it does not natively run in the browser. So having a package that has sync set up ready to go that runs on OPFS and just kind of works is something that one of our engineers, Nikita, is responsible for pretty much the entire feature. He has a really cool demonstration, and there's going to be I'm not sure when he's doing his demo. I don't know if it is for P99 Conf or if there's something getting released. I think maybe a blog post coming up here soon might have like a demo of it. But there's a really cool app that him and another one of our devs put together. It is pretty exciting stuff. We also have so like I mentioned, like regular sync is pushing and pulling wall frames. Some other features that we plan on having are partial sync, which allow you to, so if it's just wall frames, right, they're essentially just bytes, and it would be like a physical, right, these are just bytes, and we have, the offsets, and we know the file format. We don't know, like, what tuples they are or anything like that. So where there's no ability to say, I want to sync this table, right, but not these other tables. So partial sync is on is certainly on the to-do list there, something that we want to support. And then currently we already have CDC implemented too, so kind of like row level sync, like that's just basic like change data capture CDC for anyone that's not familiar. But that essentially just keeps a row level log on an internal table and makes it easier to resolve conflicts between client and server.
Oh, that's super cool. So if I'm understanding correctly, the Turso sync, you could have two clients out anywhere, out in the field somewhere, and then both of those are syncing back to a Turso cloud database, and that's the source of truth that is coordinating pushing wall frames out, or that's being asked to pull wall frames from. Is that correct?
Yes, essentially.
Okay.
Like in that case, you would essentially have like a replica of each SQLite file, and as writes are happening remotely from wherever, right, it's a web application, you could have the clients just getting this like kind of automatically fetching and pulling wall frames from remote and kind of keeping the state like up to date regardless of whether or not it maintains like a constant like WebSocket or whatever connection, right? That is the goal there. But we were highly limited by libsql and essentially like the kind of general architecture. We are making sync like first priority, like first class citizen, and are able to obviously get a lot more low level when we wrote the whole database from scratch. So
Right.
super excited about sync.
And this, I think, brings up another proper noun, which we have not talked about, which is libsql, which was, bear with me, libsql was Turso's, the company Turso's first crack at a better SQLite, which was a fork of SQLite, basically trying to improve it while still maintaining mergeability should the SQLite team ever decide, hey, we want some of those features. Turso was happy to give them back, went all the way down that road with libsql, which was a fork, ran into too many issues and decided to rewrite from scratch. So now we have all of these things that we're talking about today because you all are in full control of the entire thing. Is that right?
Yeah.
Okay. And so for going back to change data capture, does this enable either presently or in the future something where I can like say, hey, I want to subscribe to this record, and anytime this record changes, I want to fire an event in my server-side language or whatever. Does this enable that sort of thing going forward, or is that available now, or am I missing something altogether?
So that exact functionality is not available this second, but essentially all the plumbing is there, and this is like what's so great about writing everything from scratch, right? I
It's
actually
nice to own
had
the universe. Yeah, that sounds pretty great.
it is for sure, and so I wrote the like extension library, and one of the I actually don't think it got I don't think it got merged, but So far, the only extensions that, it's like, so if a listener or whatever like wants to write a extension for Turso DB, you can write it in Rust, and have, like a first class API to, you define a crate, and there's like all kinds of proc macros that make it really, really fun and easy. But the cool part is we're kind of able to hook into internals in ways that you really can't do with SQLite. And I actually wrote an extension like API that would just allow you to call, like, so you could write an extension that calls arbitrary, like whatever you want, by defining a type on your column. And anytime there's an insert, update, delete, whatever, to that column that has your type that's like specified from your special extension, it will just call your arbitrary code with the value of whatever is like inserted. So that was kind of my idea for this like extension type, was like, like a whole new way of saying like a default value of like call this like library, like whatever,
do whatever you want.
Exactly. And I thought that was like super cool. It was like really, really early. I was probably like 10 months ago or something, that I did that. And that honestly kind of reminds me to maybe revive that one. But there's like so much cool stuff you can do.
Yeah, I can tell you're excited by that one. That's cool. I like that. You should revive that one. So I wanna end here in a second with like future of Turso things you're like excited about. But is there anything else that we haven't talked about, either from launch week or the parts of the code that you're deep in that you kind of feel excited and want to talk about before we move into the future?
I don't know. I feel like we got to cover a good bit. I know I'm probably like, I like don't even think maybe you can edit this part out, but I like didn't even really read like all the beta really. I've been like so deep in the weeds of like getting foreign keys done and stuff that I've been like probably slacked on some of the promotional reading and stuff I should have been doing, but.
Talk to me about foreign keys. Tell me some of the trials and tribulations of implementing foreign keys, because that sounds like it may touch your nemesis, the B trees, the B plus trees. So tell me about the foreign key dilemma here. How hard was that to get done?
That was a tricky one. I've like, so we have the deterministic simulation tester, right? Mm-hmm. Which is great, and like automatically creates GitHub issues if during a run it runs into a panic or any kind of like different output than SQLite, right? Like it just like it's really cool. But lately I've become a huge fan of this just particular style of fuzzing that just creates a Turso database and a SQLite database, and whatever feature you implement, you create the tables and then just kind of deterministically like seed a random number generator and spam it with input, and just assert that if we fail, that SQLite also fails, and you know what I mean. So and then maybe assert that the output or the state of the database itself is the same. But yeah, that has been I regret every feature I ever added that did not have one of these fuzzers, just because of the sheer amount of crazy edge cases that you find. But yeah, this foreign key implementation was actually mostly in the translator. So SQLite, for anyone that's maybe not aware, uses a bytecode virtual machine. So instead of just having a kind of like query plan that maybe has a bunch of like methods on it to execute this plan, that is like it SQLite has the VDBE, the virtual database engine, that steps through instructions, and very much like it's an interpreter pretty much. It's just an interpreter that can, has a pager and a way to fetch data from disk. So when you are writing implementing like insert up to anything that's like processing a statement, or even a regular like select one to whatever, like 200 divided by 5 or whatever, like select arbitrary expression, that is evaluated to you have your AST, and then that gets translated into bytecode, and you have labels, and just like if you've ever written an interpreter, it's very, very similar. So foreign keys was, I would say, like pretty much 100% of that PR, of that 5,000 line PR was in the emitter. So it was emitting labels and bytecode to make sure that this like counter that keeps track of like how many conflicts for a certain connection, and then you have different opcodes that check the value of this counter and then jump to a particular like label, right, which is just a offset into the program counter, and then so lots of work in the emitter, and lots of doing and explain in SQLite, and kind of looking at SQLite's bytecode for a particular statement or whatever.
This may be a dumb or naive question, but you all have re-implemented the VBDE, whichever one, virtual byte database, VBDE. So you all are running this virtual machine type thing as well?
Yes. Yep. That is.
Which I don't know if that's dumb or not, but you didn't have to do that, right? As long as, inputs and outputs remain the same, or did you have to do that?
That's a good, that's probably like a good, maybe that's debatable whether or not we had to do that. The level of compatibility that we seek, I think it was, it would have been very difficult to not work like that. There's some ways that it has gotten in the way, but I think there's been enough ways where it's helped, because it is honestly quite nice when you're implementing, like I implemented like update. It is quite nice to be able to just explain update set, like whatever, in SQLite, and look at the bytecode and be like, all right, like I know that I have to emit this, and this, and you can tell it gives you the values in the registers, and you can kind of just like decompile it in your head and kind of figure out exactly like, oh, okay, like that's what it's doing. I just need to, so it does make it quite, easier to rewrite.
Yeah, and I guess that's a pretty good point. If you were to not do that, you lose a lot of your reference material. I mean, this is a rewrite of SQLite, and so having SQLite is pretty good reference material. And if you like fundamentally change how the two things work, then you can't really go look at SQLite and take hints and inspiration from that at all. So, all right, that makes sense to me. I'm on board with that.
Reading SQLite source code has been one of the biggest contributors to headaches I've ever had in my life. Like,
I've heard it's a very unique style of coding. What is it about it that is so, I'll say these words, not you. What is it about it that's so bizarre that everyone mentions, like, yeah, it's very unique? What has he done, D. Richard Hip? What has he done that's so interesting?
I will preface this by saying that no one are bigger SQLite nerds than Turso employees. Like, I
agree.
We use SQLite when we probably should not use SQLite. Like, we are great lovers of SQLite. Everything internally runs on SQL. We don't have a single other database in production for cloud. It is all SQLite. All internal services are SQLite. So,
well, practice what you preach. I do like that. That's pretty good.
But yes, it is it is quite the code base. It is, I would say, it is very opinionated, and it has been written entirely by like three people, I think, like three or four people, and they have very particular kind of coding style, and yeah, it's like ANSI C, you know what I mean? So it's not like C99 or whatever. Like, pretty sure it's ANSI C, and yeah, there is. I would say that I would recommend that everyone go grab the like 4 megabyte amalgamation. I think it is or 2 megabyte file. Just the single like SQLite file, and just read some code and check it out for yourself.
Yeah,
It's
this
a good
is,
it's a
by
good
the
time.
way, after you said this is one of the major sources of headaches for you. So I don't know if your sales pitch is super good, telling people to go read it. But we'll say it's probably less headachy if you're not trying to re-implement it from scratch. So you all go grab a copy and read it. There will be no headaches for you whatsoever. Okay, so we've been going for an hour here. So let's wrap up by, I want you to tell me what you're excited about for Turso's future, what your future personally looks like in the next couple of years, and then where people can keep up with you and your story online.
Yeah, for sure. So, yeah, with Turso, we are obviously like super excited about this beta release. We are like, I would say, just like very excited about the open source community that we're building around this. I've met some like really awesome people and there's contributors from all walks of life. Obviously, I'm in prison right now, and right, like it is a really fun place. There's stuff for everyone to do. I think that's maybe something I'd like to particularly call out, is that if you're interested in contributing, and even if even if you're like not a writing databases all the time, right? Like, there is like so much cool stuff to work on. There's a CLI, there's like bindings for all the languages. There's cool stuff to do, and stop by the Discord. Very welcoming to contributors. Love the open source community, and yeah, we're excited about these new features, particularly like sync. We want to make some of these things like first class, and really try to like I would say, I don't want to say like fix like SQLite, but yeah, like we've like listened to the community and like what like I think people are looking for, and we're excited to provide that for sure. As far as me personally, I should have been out of here a year ago, to be honest. I get out right now in May. I have been trying to get some like essentially like some time off for like good behavior that I have definitely earned, that they just don't want to give me. And yeah, so hoping to be out of here as soon as I can, but right now it's looking like May.
That's less than a year.
It is, yeah, 7 months.
How does, like, I mean, how do you even begin to process that mentally? Like, what?
I don't know. I'm ready, man. I'm ready. Like,
I'm sure.
I'm like, I did my sentence. The sentence that I was convicted of. That sentence ended in 2024. I'm doing time right now for marijuana from 2013.
Oh gosh.
So I am over it.
Yeah.
I'm ready. I'm ready to go home. I have a house. I bought a house across the street from my parents that live in Michigan.
I cannot even begin to comprehend how excited your parents are going to be to have you both out and home and across the street. That's a lot to look forward to.
Yeah, no, it definitely is. Super excited, and yeah, I May is going to be huge. I definitely plan on sticking at Turso. It's a great job. It's what I spent all my time on all my free time on my last job. So it is like your favorite side project to hack on. Like the fact that I get to do that for a living is like incredible, and I'm super grateful.
Yeah, not a bad deal. Where can people follow you online? And is there any parting words you want to leave with the audience before we wrap here?
Yeah, so I'm not. I guess GitHub is probably the most. I have an X account that I don't run myself as it's not, the rules and everything. But yeah, you can certainly follow me on GitHub, X, LinkedIn. I have a blog at pthorpe92.dev. And yeah.
I'll leave links to all of that below, including the 2 blog posts that you wrote, one of which you mentioned got to the top of Hacker News. And so some people have probably seen that. They've probably heard Prime talk about you. They might have heard, I don't know if Glauber told you, that you were mentioned on My First Million, the podcast. Did you know that?
I think he actually sent that to me, but he didn't tell me like why. So I was like, didn't watch the whole thing. I was like, oh, cool. And then I think later on I was like, oh, like they actually like talk about me there.
Oh, no, they did. I sent it to Glauber. That's how he knew about it. Because I was listening to My First Million and they were like, oh, dude, this is crazy story. This guy, Preston Thorpe, he works for this company called Turso. And I'm like, wait, what is happening? And so I immediately took a screenshot and sent it to Glauber. Yeah, they did you were one of 3 people they talked about on that episode. They were like, hey, we got 3 awesome stories for you. And one of them was you. So I'll leave a link to that down below as well. And if Preston, if you haven't heard it, you got to go listen to it too. It's pretty awesome. Okay, well, we'll wrap it up there. Thank you so much for doing this. I am very honored that you took your time to do this. And I just want to tell you how inspiring and impressive your story is. And I think in the same situation, in the same circumstances, very, very few people would have made this turnaround like you did. And I think that's very inspiring. And I hope that you feel very proud of yourself in this situation, because I'm very proud of you.
Well, thanks, man. It means a lot. I really appreciate that. Yeah, no, I am what ended up coming out of all this is orders of magnitude better than I ever could have expected. At the beginning, I think I was just hoping that by the time I got out, I could have like enough skill to be able to eventually have a career. I never could have guessed that things would have worked out this well. So I'm super grateful, and yeah, no, that means a lot. Thank you.
Oh. You're welcome. This has been a joy. For all you listening, if you're listening on RSS, there's a YouTube channel, which I would love if you subscribe to. That would help me out a whole lot. If you're watching on YouTube for the first time, there will be more videos on this channel, or you can subscribe via RSS in your podcast player of choice. And if you want to have somebody come on, y'all please leave comments down below, or tweet me on, I guess, X now, and tell me who you want to have on. This is all, there's no pay to play, there's no pitching, it's all just me talking to friends. So let me know who you want to have on, what tech you want to hear about, that sort of thing. And until the next time, we will talk to you soon. Thanks for tuning in to Database School. See ya.